Good morning. This is your Stat Sensei, Mr. Spensei, and this is part of the test review. And we're going to do a confidence interval for a highly caffeinated. Specifically, it says create a 91% confidence interval for the amount of caffeine consumed. So let's go back and look at the scenario, which is in our warm up. There are more than 10 million young adults. That's our population. However, in this video, we're not going to worry about conditions only because we did it in the hypothesis test. So if you want to catch the conditions, you'll need to go to the hypothesis test. So there are more than 10 million young adults that consume caffeinated beverages in the United States. A coffee company asserts that the average U.S. adults consume an average of 180. So we're claiming that adults consume 180. A nutritionist believes that young adults consume more than 180 milligrams and collects data from a random sample of 95. So we have 95 young adults. Random sample is the condition. 95 is our sample size. Finding that the average caffeine intake is 190.3 milligrams per day. So this is our X bar with a sample standard deviation of 45. All right, and they want us to create a 91% confidence interval. Well, to do that, I'm going to need my formula. All right. And my formula is X bar plus or minus T star S divided by square root of N. Notice there are no D's on it. Why? This is not paired. So please don't put D's on it unless it's paired. You know it's paired if it's before and after. These were only tested one time. There was no pairing going on. Let's go ahead and calculate our T star because we know we want a 91%. To do that, we're going to have to go to second vars, inverse T, parenthesis 1 minus 0.91, close parenthesis, divided by 2. Now it asks for our degrees of freedom. Please remember, degrees of freedom are our sample size minus 1. Well, our sample size was 95, so 95 minus 1. And there we get 1.7130. And that is our T star. Notice mine's negative, but we're always going to be positive. So this should always be a positive statement. All right, so please always make that positive. All right, going back to the writing, what is our important information? Well, X bar is 190.3 milligrams consuming caffeine. Our sample size is 95. Our sample standard deviation is 45 milligrams. And notice we don't care about the population because we're trying to estimate the population from the sample. And our sample, and please remember, degrees of freedom is specifically N minus 1. So in this case, 95 minus 1. All right, plugging in X bar. So this is our X bar right here. This right here is my T star. I guess I could have labeled X bar here. That'd be better. This is my S of X, my standard deviation, and this is my sample size. Remember T star, we calculated it right there from above. All right. Confidence intervals are always centered on X bar. Hypothesis tests are centered on the population mean. Confidence intervals are centered on X bar. So we need to be centered on 190.3, and we have a 91% interval. All right, we're going to go run a one sample T interval for means. We do not need to say paired because it's not paired. If you write paired, that's incorrect. Nothing was tested twice. There was no before and after situation. So because there's no before and after, nothing tested twice, it's not paired. All right, running the test. Stat, test, drop down to number 8, T interval. All right, stats should be highlighted because we don't have data. Our X bar is 190.3. Our sample standard deviation is 45. And we want to run a 91% interval. Oh, our sample size is 95, and we want to run a 91% interval, so 0.91. Calculate, and we get 182.39 to 198.21. So here's my lower bound and my upper bound. All right, we're still going to redefine our parameter even though we've done that previously. Let mu, no D, because there's no differences. We're not doing paired. True population mean amount of caffeine consumed daily. Great. Conditions, if you want to see those, they're in the hypothesis test video. Go watch that. We're not going to do conditions here because we don't want to be redundant. So we are 91% confident, because that's our confidence level, that the true population mean amount of caffeine consumed daily, this part right here is our parameter, lies within the interval 182.39 to 198.21. Please remember, this is just a restatement of what we calculated above. All right. Finally, the meaning. In repeated sampling, we expect this method to capture the parameter, the true population mean amount of caffeine consumed daily, and that is the parameter 91% of the time, because that's our confidence level. All right, I appreciate you watching. This concludes this video. I sure hope to see you on the next one. Thank you.